Hello, in this lecture we find out the maximum area of a rectangle inside a triangle. In the drawing we have triangle ABC, side AB equals to 10 units in its length, side AC of triangle ABC equals to 17 units in its length, side BC equals to 21 units in its length. Inside this triangle ABC we have this rectangle PQST, and our mission is to find out the maximum area of this rectangle PQST. Okay, so in the first step we do a construction. That is to say, from point A we draw perpendicular on PQ. Again, from point A we draw perpendicular on PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. In the next step we define the touching point of the perpendicular from point A and PQ. This point is point M. In the next step we will extend the perpendicular AM until it touches side BC. And we will define the touching point of the extended perpendicular AM with side BC. This point is point N. By doing this construction, we created here two corresponding angles. Those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees, because of the fact that those two angles are equal to each other. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees. In the next step, we define the length of this line segment BN as X. So what is the length of this line segment NC? From the drawing it is very easy to see that NC equals to BC minus BN. So I write it down. NC equals to BC minus BN. BC equals to 21 units in its length, and this line segment BN equals to X according to our definition. So in total, NC equals to 21 minus X. So this line segment NC is equals to 21 minus X units in its length. And again, this line segment NC equals to 21 minus X units in its length. In the next step, I'll copy this right triangle A and B in a new page, and we'll implement on this right triangle A and B the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the relation for Pythagoras theorem. side BN equals to x units in its length. The hypotenuse AB equals to 10 units in its length, according to what is given as the question. So actually, this is the right triangle ABN that are coming from the original drawing. According to the Pythagoras theorem, in this right triangle ABN, AB squared equals to BN squared plus AN squared. And again, this right triangle ABN, according to the Pythagoras theorem, AB squared equals to BN squared plus AN squared. So here we subtract BN squared from this equation, and you get that according to this equation, equation 1, AN squared equals to AB squared minus BN squared. So AN squared equals to AB squared. The hypotenuse AB equals to 10, therefore AB squared is 10 squared, that is 100, minus BN squared. BN equals to x, therefore BN squared is x squared. So according to equation 1, we should find out that AN squared equals to 100 plus x squared. In the next step, I'll copy this right triangle ANC in a new page, and we implement on this right triangle ANC the Pythagoras theorem. Again, here by PT is the abbreviation for Pythagoras theorem. Side NC of the rectangle ANC equals to 21 minus x units in its length. The hypotenuse AC equals to 17 units in its length, according to what is given as the question. So actually, this is the right triangle ANC. This is according to the original drawing, according to the Pythagoras theorem. In this right triangle ANC, AC squared equals to NC squared plus AN squared. So here we subtract AN squared from this equation, equation 2. Here we subtract NC squared from this equation, equation 2. And you get that according to this equation, equation 2, AN squared equals to AC squared minus NC squared. So according to this equation, equation 2, AN squared equals to AC squared. AC is 17, therefore AC squared is 17 squared, that is 289 minus NC squared. NC is 21 minus x, therefore NC squared is 21 minus x squared. So according to equation 2, we actually found out that AN squared equals to 289 minus 21 minus x squared. This is according to equation 2. According to equation 1, we have already found out that AN squared equals to 100 minus x squared. So here we have two equations for AN squared. Two different equations for an squared. Therefore, we create equation 3 that states that an squared, according to equation 1, must be equal to an squared according to equation 2. Okay? So an squared according to equation 1 equals to 100 minus x squared, and that's equal to an squared according to equation 2, and an squared according to equation 2 equals to 289 minus 21 minus x squared. 21 minus x squared. So according to equation 3, I found out actually that 100 minus x squared, that is an squared according to equation 1, equals to 289 minus 21 minus x squared. This is an squared according to equation 2. So here we'll open the brackets of this expression 21 minus x squared, and we get that according to this equation, equation 3, 100 minus x squared equals to, here we have 289 minus, and here we have the expression 21 minus x squared. 21 minus x squared equals to 21 squared, that is 441 plus x squared minus 2 times 21, that is minus 42 times x. So it is in total 42x. So here we open the brackets on this expression, and you get that according to this equation, equation 3, 100 minus x squared equals to 289. So after we open the brackets here, this expression will be equal to minus 441. Here we have minus x squared, and then we have minus times minus is plus. Minus 42x is plus 42x. So according to equation 3, we can find out that 100 minus x squared equals to 289 minus 441 minus x squared plus 22x. So here we have minus x squared on both sides of the equation. So minus x squared will get cancelled. After we cancel minus x squared, in this side of the equation we left only with 100, and it is equal to the other side of the equation we have 289 minus 441 plus 42x. So here we get 441 to this equation, equation 3, and we get that according to this equation, equation 3, 100 plus 441 equals to 541, and it is equals to, here we have 289 plus 42x. So here we subtract 289 from this equation, equation 3, and finally we get that 541 minus 289 is equal to 252. And in the side of the equation we left only with 42x. So according to equation 3, we found out that 252 equals to 42x. So here we divide this equation 3 by 42, and finally we get that according to this equation 3, x equals to 252 over 42 is 6. So x equals to 6 units in its length. So here, this is line 7bn, that's equal to x is equals to 6 units in its length. And this is line 7nc, that equals to 21 minus x, and x is 6, therefore it is 21 minus 5, that is 15. In the next step, we return to equation 1. According to equation 1, an squared equals to 100 minus x squared. But we just right now found out that x equals to 6, therefore x squared equals to 6 squared, that is 36. So in total, an squared according to equation 1 is equals to 100 minus 36, and 100 minus 36 is 64. So according to equation 1, I should found out that an squared equals to 64. Here we take a root out of this equation 1, and we get that an equals to the square root of 64, that is 8. So here, this is 97 an, that's equal to 8 units in its length, so I write it down here, an equals to 8 units in its length. In the next step, we define the width of this rectangle PQST, that is to say QS, we define the width QS as B. So QS equals to B according to our definition, and we define the length of this rectangle PQST, that is to say we define the length PQ as A. So here PQ equals to A according to our definition, and the length QS equals to B also according to our definition. Those two angles, that is to say angle APM, and this angle that is actually angle ABC, those two angles are defined as corresponding angles. Those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if this angle equals to alpha, then this angle must be also equal to alpha, because they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. Again, those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. So if this angle equals to beta, then this angle must be also equal to beta, because they are equal to each other according to the rule that I mentioned. The corresponding angles between parallel lines are equal to each other. So in the next step, we prove that the big triangle ABC, this is the big triangle ABC, is similar to this small triangle APQ. Again, repeat again, we prove that the big triangle ABC is similar to the small triangle, triangle APQ. We know that if two triangles are similar to each other, then the ratio between their heights is equal to the ratio between their sides, or the ratio between their corresponding heights must be equal to the ratio between corresponding sides. Okay? So why the big triangle ABC is similar to the small triangle APQ? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, that is a common angle that belongs to both triangles. So angle A equals to itself as a common angle that belongs to both triangles. In conclusion, we found out that all the three angles of the big triangle ABC are correspondingly equal to all the three angles of the small triangle APQ. Therefore, those two triangles are similar to each other according to angle similarity rule. So write it down. The big triangle ABC is similar. This is the sign of similar to the small triangle, triangle APQ, according to angle similarity rule. And therefore, the corresponding heights and those two similar triangles must be equal to the corresponding sides of those two similar triangles. That is to say, the height AM in the small triangle APQ over the height AN in the big triangle ABC must be equal to the side of the small triangle PQ over the side of the big triangle BC, with the big triangle ABC, BC. Repeat again, because of the fact that the big triangle ABC is similar to the small triangle APQ, then AM over AN, that is the ratio between their corresponding heights, must be equal to PQ over BC. That is actually the ratio between their corresponding sides. But before I continue, we'll focus on this small quadrilateral MQSN. This small quadrilateral MQSN, those two angles, they are both right angles because they are part of the two angles of rectangle PQSN. Therefore, those two angles, they are both right angles. So this angle equals to 90 degrees in its size. And this angle also equals to 90 degrees in its size. I'll repeat again, because of the fact that those two angles, they are part of the two angles of a rectangle PQST. And we know that all the angles inside any rectangle are right angles. So inside this small quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral MQSN, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to this quadrilateral MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle in the form of a rectangle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. So what is the length of this line segment AM? From the drawing it is very easy to see that AM equals to AN minus MN. And again, this line segment AM is equal to AN minus MN. So AM equals to AN, that is 8. AN equals to 8 minus MN. We just found out that MN equals to B. So in total, AM equals to 8 minus B units in its length. And again, AM, this is side AM, that is equals to 8 minus B units in its length. So now we continue with what we started here. We actually found out that the big triangle ABC is similar to the small triangle APQ, and therefore the following equation is true, that AM over AN equals to PQ over BC. That is to say, the ratio between the heights of the two similar triangles is equal to the ratio between the sides of the two similar triangles. We just right now found out that AM equals to 8 minus B, therefore we substitute AM by 8 minus B over AN. AN equals to 8. So we substitute AN by 8, and it is equals to PQ. PQ is A, it is the length of rectangle PQST, and according to the definition, the length of rectangle PQST is equals to A. So PQ equals to A, therefore we substitute PQ by A, but we substitute PQ by A, it is PQ over BC, and BC equals to 21 units in its length according to what is given as the question. So in conclusion, we found out that according to equation 1, 8 minus B over 8 equals to A over 21. Here we cross multiply this equation, equation 1, and you get that according to this equation, equation 1, A equals to 21 times 8 minus B. So here we divide this equation, equation 1 by 8. And you get that according to this equation, equation 1, A, it is the length of rectangle PQST. A equals to 21 over 8 times 8 minus B. So here we'll open the brackets of this side of this equation, equation 1, and we get that according to this equation, equation 1, A equals to 21 times 8 over 8 is 21, and here we have 21 over 8 times minus B equals to minus 21 B over 8. So in conclusion, we found out that according to equation 1, A equals to 21 minus 21 B over 8. Here we multiply this equation, equation 1 by B, and you get that according to this equation, equation 1, here we have A, so A, we multiply it by B, so it is A times B, 8 times B, equals to, here we have to multiply also this side of the equation by b. So 8 times b equals to 21b. And here we have minus 21 over 8b times b equals to minus 21 over 8b squared. So in conclusion, according to equation 1, we actually found out that a times b equals to 21b minus 21 over 8b squared. But what is the expression a times b? A is the length of this rectangle PQST, and b is the width QS of this rectangle PQST. And the width times the length is the area of this rectangle PQST, that is the area that we are looking for. So we found out that the area of rectangle PQST, that is to say AB equals to 21b minus 21 over 8 times b squared. So actually have the area of this rectangle PQST according to the independent variable b, that is the width of this rectangle PQST. And our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of this area function of rectangle PQST. And we know that the area of rectangle PQST equals to 21 times b minus 21 over 8 times b squared. So in order to find out the maximum value of this function, or the function area of rectangle PQST, we will have to differentiate this function area and to equate the derivative to 0. In this way, we find out the extreme points of this function area. And the extreme point might be a minimum extreme point. That is to say, we might get the minimum area of this rectangle PQST, but it might also be the maximum area of this rectangle PQST. In order to verify that the extreme point that we found by differentiating the function area and then equating it to 0, in order to verify that the extreme point is maximum extreme point and not minimum extreme point, you have to draw the function of this rectangle, the area function of this rectangle PQST, and from the graph we'll see whether if the extreme point that we got is a maximum point or a minimum point. So in the first step we will differentiate this function area of rectangle PQST. That is to say, we take the derivative, this information for derivative, we take the derivative of this function area, this is actually 21b minus 21 over 8 times b squared. And we take the derivative according to the variable b. So this equation means that we'll take the derivative of this function area, that is actually 21b minus 21 over 8 times b squared, according to the independent variable b. B is the independent variable on this function area. And the dependent variable is the area itself. The area itself is AB, and the area is dependent on the value of b. That is the independent variable. And so we will differentiate the function area and we'll equate this derivative to 0. Okay, repeat again. The mean of this equation 2 that we took the derivative of this function area and we equate it to 0. Okay. So what is the derivative of 21b? Actually, we know that the derivative of b is 1. The derivative of b is 1, therefore in total this expression equals to 21 times 1, that is 21. That is to say the derivative of 21b is 21. And what is the derivative of 121 over 8 times b squared? Actually, we know that the derivative of b squared is 2b, and therefore this expression will be equal to minus 21 over 8 times 2b. After we took the derivative of this expression, b squared will become 2b because the derivative of b squared is 2b. And it equals to 0. So actually found out that the derivative of the function area, that is actually 21b minus 21 over 8 times b squared, is equals to 21 minus 21 over 8 times 2b, and we have to equate the derivative of this function area to 0. Okay. In the next step, we took 21 as a common factor from those two expressions. So 21 is taken out as a common factor from those two expressions. So what is left of 21 after we took from it 21 as a common factor? What is left is actually 1. And what is left from this expression minus 21 over 8 times 2b after we took from it 21 as a common factor, what is left is actually minus 2b over 8, and it equals to 0. Here we divide this equation 2 by 21, and get that according to this equation 2, 21 over 21 is 1. So in this side of the equation, we left only with 1 minus 2b over 8. And we have to divide the other side also by 21. 0 over 21 is 0. So in conclusion, we found out that according to equation 2, y minus 2b over 8 equals to 0. Here, we will add 2b over 8 to this equation 2. And again, that according to this equation 2, 1 equals to 2b over 8. Here we divide both the numerator and the denominator of this expression by 2. And we get that according to this equation 2, 1 equals to 2b over 2 is b. And 8 over 2 is 4. So in conclusion, according to equation 2, we actually found out that 1 equals to b over 4. 1 equals to b over 4. We will multiply this equation 2 by 4. And finally we get that according to equation 2, b equals to 4 units. That is to say, we actually found out that the extreme point of this function area of rectangle PQST is at point B that is equal to 4 units. But again, the extreme point of the function area of this rectangle PQST that is actually equals to 21b minus 21b squared over 8 is at point B that is equal to 4. Okay. Now we have to verify that the extreme point, that is to say that b equals to 4, that b equals to 4 is the maximum extreme point and not minimum extreme point. In order to verify that b equals to 4 is the maximum extreme point, we have to draw the function area of this rectangle PQST. Actually, draw the function area of this rectangle PQST. This is the function area of rectangle PQST. This is to say the area of rectangle PQST, that is a times b, is equal to 21b minus 21 over 8 times b squared. So this is the function area of the rectangle. And from this function area, here the y-axis is the area, and in the x-axis we have the width b. Repeat again, in the x-axis we have the width b, and in the y-axis we have the area. And from this graph it is very easy to see that when b equals to 4, here, when b equals to 4 units in its length, then the area of rectangle PQST is at its maximum value, and that is to say it is a little bit above 40. So from this function area, you can say that point 4 is the maximum extreme point and not minimum extreme point. Now we find out what is the exact value of this rectangle PQST when b equals to 4. In order to find out what is the exact value of this rectangle PQST when b equals to 4 units inside, that is to say when the width is 4, we will have to substitute in the function area that is equals to AB equals to 21b minus 21 over 8 times b squared. We will have to substitute b in this function area of this rectangle PQST by 4. So we substitute b by 4 in order to find out the maximum area of this rectangle PQST. We do it now and we get that the area that is a times b is equals to 21b. b is 4, therefore we substitute b by 4. So it is 21 times 4 minus 21 over 8 times b squared. b equals to 4, therefore b squared is 4 squared, that is 16. So we found out that the maximum area of this rectangle PQST is when b equals to 4, and when b equals to 4, the area is equal to 21 times 4, because b is 4. We substitute b by 4, minus 21 over 8 times b squared, that is 16. So the maximum area of this rectangle PQST will be equal to 21 times 4, that is 84, minus here, what is the value of this expression? 16 over 8 is 2, and 2 minus 21 is minus 42. So the maximum area of rectangle a times b is 84 minus 42, that is 42. So actually found out that when b equals to 4, we have the maximum area of this rectangle PQST, and the maximum area of rectangle PQST is equals to 42 square units. And in this case, the width is 4 and the length is A. In order to find out what is the value of A, we have to put the value of B in the equation for A. We have already found out that A equals to A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4, because when B equals to 4, we have the maximum area, that is 42 square units of rectangle PQST. So we substitute B by 4. So A equals to 21, and here we have minus 21 over 8, and B is 4. So A in total equals to 8, that is the length of rectangle PQST, equals to 21. And here we have, we divide both the numerator and the denominator of this expression by 4. 4 over 4 is 1. So in the numerator we have 21 over 8 over 4 is 2. So if we found out that the maximum area of rectangle PQST, that is 42, then the width is 4 and the length is 21 minus 21 over 2. So it is 21 minus 21 over 2 is 10.5. So the length A equals to 21 minus 10.5. 21 minus 10.5 equals to 10.5. So if we found out that the length of rectangle PQST equals to 10.5 units, the width B is 4, and the area is A times B, that is 10.5 times 4, that is 42 square units, and that is actually the maximum area of this rectangle PQST. Why? Because we found out that when B equals to 4, then when B equals to 4, 4 is the extreme point of this rectangle PQST, and according to this graph, that is the graph of the function area of rectangle PQST, when B equals to 4, the area is at its maximum value. You can see that when B equals to 4, then the area equals to 42 square units. So we found out that the maximum area of this rectangle PQST is equals to 42 square units. Okay, so in the next step I will summarize the lecture. So in this lecture we found out the maximum area of this rectangle PQST that is located inside this triangle ABC. So in the drawing we have triangle ABC. We know that side AB of this triangle ABC equals to 10 units inside, side AC equals to 17 units inside, side BC equals to 21 units inside. So inside this triangle ABC we have this rectangle PQST. And our mission is to find out the maximum area of this rectangle PQST. This is rectangle PQST, and we have to find out the maximum area of this rectangle PQST. So in the first step, we did a construction. That is to say, from point A we draw perpendicular on PQ. Again, from point A we draw perpendicular on PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ, this point as M. In the next step, we extended the perpendicular AM by straight line until it touches side BC, and we find the touching point of the extended perpendicular AM with side BC. This point is point N. Actually, by doing this construction, we created those two angles, and those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. But this corresponding angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees. Okay, so in the next step, we defined the length of this isosceles BN as X. So what is the length of NC? NC equals to BC minus BN. Again, NC equals to BC minus BN. So NC equals to BC, that is 21 according to what is given us in the question, minus BN. BN is X according to our definition. So in total, NC equals to 21 minus X. In the next step, I copied this right triangle A, BN in a new page, and implemented the Pythagoras theorem on this right triangle, triangle A and B. This is the right triangle A and B that I copied from the original drawing. Here, by PT, is the version for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse AB equals to 10, side BN equals to X according to our definition. Side AN is the missing side. So in this right triangle ABN, according to the Pythagoras theorem, AB square equals to BN square plus AN square. Here we subtracted BN square from this equation, equation 1, and finally found out that AN square here AN square equals to AB square minus BN square. This is according to equation 1. But here AB is 10, therefore AB square is 10 squared, that is 100, minus BN square. BN is X, therefore BN square is X squared. So in total, according to equation 1, we actually found out that AN square equals to 100 minus X square. In the next step, I copied this right triangle, triangle A and C, in a new page, and we created the Pythagoras theorem on this right triangle A and C. This is the right triangle A and C that I copied from the original drawing. The hypotenuse AC equals to 17 units instead, according to what is given in the question. We already found out that NC equals to 21 minus X, and AN is the missing side. So in this right triangle A and C, according to the Pythagoras theorem, AC square equals to NC square plus AN square. Again, AC square equals to NC square plus AN square. Here we subtracted NC square from this equation, equation 2, and finally found out that AN square equals to AC square minus AN square equals to AC square minus NC square. So AN square equals to AC square minus NC square. This is according to equation 2. So AN square equals to AC square. The hypotenuse AC equals to 17, therefore AC square is 17 squared, that is 289 minus NC square. NC is 21 minus X, therefore NC square is 21 minus X square. So in conclusion, according to equation 2, we found out that AN square equals to 289 minus 21 minus X square. This is according to equation 2, and according to equation 1, we already found out that AN square equals to 100 minus X square. So we have two different equations for the value of an squared, we get the equation 3 that states that an squared according to equation 1 must be equal to an squared according to equation 2. So an squared according to equation 1 equals to 100 minus x squared. And it must be equal to an squared according to equation 2. An squared according to equation 2 equals to 289 minus 21 minus x squared. Here, we open the brackets of this expression 21 minus x squared and found out actually that 100 minus x squared equals to 289, and we have minus, and the expression 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 221, that is minus 42 times x. So it is in total minus 42x. So according to equation 3, we found out that 100 minus x squared equals to 281 minus, inside the brackets we have 441 plus x squared minus 42x. Here we open the brackets of this expression and finally found out that according to this equation 3, 100 minus x squared equals to 289, and after we open the brackets, we get here this expression will be equal to minus 441. Here it is minus x squared, and minus times minus is plus, so here we get plus 42x. So here we have x squared on both sides of this equation 3, therefore x squared will get cancelled. After we cancel x squared, in this side of the equation 3, of equation number 3, we left with 100, and the other side of the equation we left with 289 minus 441 plus 42x. Here we added 441 to this equation 3, and finally found out that according to this equation 3, 441 plus 100, 441 plus 100 equals to 541, and it equals to 289 plus 42x. So according to equation 3, in total we found out that 541 equals to 289 plus 42x. Here we subtracted 289 from this equation 3, and finally found out that 541 minus 289 equals to 259, and 259 equals to 42x. Here we divided this equation 3 by 42, and finally found out that x equals to 259 over 42 is 6. So x equals to 6 units in its length. So here, line segment BN is equal to x is equal to 6, and here this is line segment NC or CN that is equals to 21 minus x, and x is 6, therefore it is 21 minus 6, that is 15. The next step, we turn to our equation 1. According to equation 1, we found out actually that an squared equals to 100 minus x squared. But x equals to 6, therefore x squared is 6 squared, that is 36. So in total, according to this equation 1, an squared equals to 100 and x squared is 36. So in total, according to equation 1, an squared equals to 100 minus 36, that is 64. So according to this equation 1, we found out that an squared equals to 64. We took out of this equation and finally found out that an equals to the square root of 64, that is 8. So here, this is line segment AN, that is equal to 8 units in its length. In the next step, we define the width, that's actually QS of this rectangle PQST as B, and we define the length PQ of this rectangle PQST as A. That is to say, PQ equals to A according to our definition, and the width QS equals to B also according to our definition. Those two angles, they are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because those two angles are equal to each other. Likewise, those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they must be equal to each other according to the same rule. So if this angle is beta, then this angle must be also equal to beta. In the next step, we proved that the big triangle ABC is similar to this small right triangle APQ. So why those two triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, that is a common angle, it belongs to both triangles, so we can write down that angle A equals to itself. It's a common angle that belongs to both triangles. So we should prove that all the three angles of the big triangle ABC are corresponding equal to all the three angles of the small triangle APQ. Therefore, those two triangles are similar to each other according to angle similarity rule. Repeat again. The right big triangle ABC similar. The big triangle ABC similar to the small triangle APQ according to angle similarity rule. And whenever you have two similar triangles, then the ratio between their heights is equal to the ratio between their sides. I repeat again, the ratio between their corresponding sides must be equal to the ratio between their corresponding heights. And therefore, the height AM in the small triangle APQ over the height AN in the big triangle ABC must be equal to side PQ of the small triangle APQ over side BC of the big triangle ABC. I repeat again, because of the fact that the big triangle ABC is similar to the small triangle APQ, we will derive from it that AM over AN, that is the ratio between the heights of the two similar triangles, that is to say ABC and APQ, it is equal to the ratio between their corresponding sides, that is PQ is the size of the small triangle over BC, that is the side of the big triangle ABC. So in conclusion, according to equation 1, we found out that AM over AN equals to PQ over BC. But here, we have already found out that AN equals to 8. In the next step, we focused on this small quadrangle MQSN. In this small quadrangle MQSN, we have 1, 2, 3 right angles. Those two angles are right angles because of the fact that they are the two angles of rectangle PQST, and we note that all the angles inside any rectangle are right angles. Therefore, those two angles are right angles. So inside the small quadrangle MQSN, we have 1, 2, 3 right angles. The sum of three right angles is 270 degrees. So 270 degrees plus the size of this fourth incident angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this fourth incident angle must be equal to 90 degrees in its size. So inside the small quadrangle MQSN, we have 4 right angles, and according to rule 6, any quadrangle that has 4 right angles must be this rectangle if not a square. So we relate to this small quadrangle MQSN as a rectangle because it has 4 right angles. So quadrangle MQSN is a rectangle, but we also know that the opposite sides of rectangle are equal to each other. So in the small rectangle MQSN, side QS must be equal to the opposite side MN. But QS equals to B according to the definition, therefore MN must be also equal to B. And therefore AM equals to AN minus MN. Again, AM equals to AN minus MN. So AM equals to AN, that is 8, minus MN, that is B. So in total, AM equals to 8 minus B. Again, AM equals to 8 minus B. And therefore, we have here the equation that AM over AN equals to PQ over BC. So we just right now found out that AM equals to 8 minus B. We have already found out that AN equals to 8. PQ is the length of rectangle PQST, and it is equals to A according to our definition. So we substitute PQ by A over BC. BC is 21 units according to what is given as the question. So in conclusion, according to equation 1, we actually found out that 8 minus B over 8 equals to A over 21. Here we cross multiply this equation with equation 1 and finally found out According to this equation 1, 8a equals to 21 times 8 minus b. Here we divided this equation 1 by 8 and finally found out that a equals to 21 over 8 times 8 minus b. So here we open the brackets on this side for this equation 1 and finally found out that a equals to 21 over 8 times 8 is 21, and here we have 21 over 8 times b is minus 21 over 8 times b. So here we multiply this equation 1 by b, and finally found out that a times b equals to 21b minus 21 over 8 b squared, because b times b is b squared. So in total, this expression after multiplied by b will be equal to minus 21 over 8 times b squared. So in conclusion, according to equation 1, we actually found out that a times b equals to 21b minus 21 over 8 times b squared. A is the length of this rectangle PQST, and b is the width. And know that the length times the width equals to the area of rectangle ABCD. Therefore, we found out that the area of rectangle PQST, that is a times b, equals to 21b minus 21 over 8 times b squared. So we have the area of this rectangle PQST as function of b. b is the independent variable and the area is the dependent variable, because when we determine the value of b, then the value of the area will be determined by the value of b. Okay, so actually found out the area of this rectangle PQST as function of b. Our mission is to find out the maximum area of this rectangle PQST. Or in other words, we have to find out the maximum value of this function. That is to say, we have to find out for which b the value of this expression, that is to say the area, will be at its maximum value. In order to find the maximum value of this expression, we have to differentiate this expression, that is actually the function area of this rectangle PQST. So we have to differentiate this function area and then to equate it to 0 in order to find out extreme points for this function area. And after we find out the extreme points of this function area, we check whether if the extreme point is the maximum extreme point or a minimum extreme point. And we'll do it by drawing the function area of this rectangle PQST. And from the graph, you can easily see if the extreme point that we found is a maximum area or a minimum area. Okay, so we took the derivative of this expression, that is to say we differentiate this expression, that is the area function of rectangle PQST. So the derivative of 21b minus 21 over 8 times b squared. D is the version for derivative, and we take the derivative of this function area according to the variable b. So it is d, that is the derivative of the function area 21b minus 21 over 8 times b squared according to the variable b. And we have to equate the derivative of this function area to 0 in order to find the extreme points of this function area. So what is the derivative of 21b? Actually, we know that the derivative of b is 1. Therefore, this expression will be equal in total to 21 times 1, that is 21. So in conclusion, we found out that the derivative of 21b is 21. here the derivative of 21b is 21, and what is the derivative of minus 21 over 8 times b squared? We actually know that the derivative of b squared is 2b, and therefore in total is the derivative of this expression will be equal to 21 over 8 times 2b. But again, the derivative of this expression will be equal to 21 over 8 times b times 2b, because the derivative of b squared is 2b. So in total, we shall find out that the derivative of this function area, that is 21b minus 21 over 8b squared, is equals to 21 minus 21 over 8 times 2b. And we have to equate the derivative to 0. We did it. And here, in the next step, we took 21 as a common factor out of those two expressions, from those two expressions. So here, what is left from 21 after we took away 21 as a common factor? What is left is actually 1. And what is left from this expression after we took from it 21 as a common factor? What is left is actually minus 2b over 8, and it is equals to 0. So here we divided this equation 2 by 21. So after we divide this equation by 21, 21 over 21 is 1. So we left only with 1 in this side of the equation, we left only with 1 minus 2b over 8. In the other side of the equation, 0 over 21 is 0. So in conclusion, according to equation 1, we found out that 1 minus 2b over 8 equals to 0. Here we added 2b over 8 to this equation 2, and finally found out that 1 equals to 2b over 8. Here we divided both the numerator and the denominator of this expression by 2. So 2b over 2 is b, and 8 over 2 is 4. So in conclusion, according to equation 2, we found out that 1 equals to b over 4. Here we multiply this equation 2 by 4, and finally found out that b equals to 4. So b equals to 4 is the extreme point of this function area, the function area of this rectangle PQST. In the next step, we have to verify that the extreme point, that is b equals to 4, it is indeed a maximum extreme point and not a minimum extreme point. So I drew the graph of the function area. This is the graph of the function area of the rectangle PQST. In the y-axis we have the area. In the x-axis we have the width b. And you can definitely see that when b equals to 4, then the area is a little bit more than 40 square units, because here we have 40, so it is a little bit more than 40 square units. So in this way, actually verified that the extreme point b equals to 4 is a maximum extreme point and not a minimum extreme point. Now, in order to find out what is the exact value of the area of rectangle PQST when b equals to 4, we have to put the value of b in the function area. That is to say, we have to substitute b by 4. We did it, and finally found out actually that again the function area is AB, that is the area of the rectangle PQST. It is equals to 21b minus 21 over 8 times b squared. So we substitute b by 4 because b is the maximum extreme point of this function area of rectangle PQST. So we substitute b by 4. So it is 21b, and b is 4, therefore it is 21 times 4 minus 21 over 8 times b squared. B is 4, therefore b squared is 4 squared, that is 16. So in conclusion, we can note that the maximum area of rectangle PQST when b equals to 4, it is equal to 21 times 4 minus 21 over 8 times 16. 21 times 4 is 84. Here, in this expression we have 16 over 8 is 2. So in total, this expression is minus 21 times 2, that is minus 42. So in conclusion, we should found out that the maximum area of a rectangle or PQST equals to 84 minus 42. 84 minus 42 is 42. So the answer to the question that the maximum area of this rectangle PQST is equal to 42 square units. And then the width of rectangle PQST when the area equals to 42 square units, the width is b, and the length is 21 minus 28 over 2 times b, and b is 4, so we have to substitute b by 4. So the length is 21 minus 21 over 8 times b, and b is 4. So the length a equals to 21 minus 21 over 8 times 4. Here we divided both the numerator and the denominator of this expression by 4 and found out actually that the length a equals to 21, and here 4 over 4 is 21 and 4 over 4 is 1, so in the numerator we left only with 21, and 8 over 4 is 2. So in conclusion, we found out that the length a of rectangle PQST when b equals to 4, the length a equals to 21 minus 21 over 2. So it is 21, and 21 over 2 is 10.5. So the length a equals to 21 minus 10.5, that is 10.5. So we found out in conclusion that the maximum area of this rectangle PQST equals to 42 square units, and when the maximum area equals to 42 square units, then the length of the rectangle is 10.5 units, and the width is 4, and they are equal to the length times the width, that is 10.5 times 4, that is 42 square units. Okay, thank you very much.